Well, thank you all. I'm so sorry that I can't be there in person, but very happy this is all happening. Ulf and I start our book by introducing the concept of reason relations, of implication and incompatibility, motivated by Harman's argument for the need to distinguish such rational relations from inferential practices. We show how such consequence and exclusion relations can be understood as amphibious between pragmatic accounts of what one's doing in using declarative sentences to say something in the sense of asserting or denying it, and semantic accounts of what one is saying, the proposition being accepted or rejected on the side of meaning. According to a bilateral, two-sorted normative pragmatic theory, for the premises gamma to imply the conclusion A is for anyone who accepts all of gamma to be precluded thereby from entitlement to deny A, in that sense to be implicitly committed to accept A. According to a modal mereological truthmaker's semantic theory, for premises gamma to imply the conclusion A is for every fusion of truthmakers of all the propositions in gamma with falsity makers of A to be impossible states. Ploebel's pragmatic semantic isomorphism invites us to think of these two very different kinds of discursive metavocabulary as offering a stereoscopic view of one single topic, reason relations. The very same relations of implication and incompatibility can be understood both in deontic normative terms, of which constellations of doxastic commitments, acceptances and rejections, are inappropriate in the sense that interlocutors cannot be jointly entitled to all of them, and in alethic modal terms, of which fusions of sets of states, truth makers and falsity makers, are impossible. This is bimodal conceptual realism about reason relations. This thesis and the pragmatic semantic isomorphism that justifies it articulate an understanding of the bilateral distinction between practical doxastic attitudes of acceptance and rejection and the bivalent distinction between semantic values of truth and falsity as manifestations of a single basic discursive bipolarity. After all, doxastic acceptance of a claimable content, of the sort paradigmatically manifested in speech acts of assertion, is practically taking or treating that content as true. And doxastic rejection of a claimable content, of the sort paradigmatically manifested in speech acts of denial, is practically taking or treating that content as false. These relations at the level of sentences between pragmatic attitudes and semantic values are not, I think, controversial. What is controversial is whether either a pragmatics first or a semantics first order of explication is possible here, whether one or the other set of opposed metaconcepts can be made sense of sufficiently independently of the other to support an explication of true or false in terms of acceptance or rejection, or the other way around. I want to start off today by suggesting that we'll not adequately understand these two manifestations of this basic discursive bipolarity, distinguishing truth from falsity and acceptance from rejection, if we remain at the level of sentences. That same bipolarity necessarily shows up also at the level of reason relations among sentences. One form it takes there is the distinction between relations of implication and relations of incompatibility. In the context of our larger argument, this claim should not be surprising, for the line of thought we develop locates the structure common to bilateral pragmatic metavocabularies and bivalent semantic metavocabularies at this higher suprasentential reason relational level. The structural and functional connections between the sentential true-false and accept-reject dyads on the one hand, and the reason relational implication-incompatibility dyad on the other are subtle and not obvious, though. We can begin to make these connections visible by thinking about the relations between classical bivalent truth values that make it possible for them to play their appointed role in semantic theory. First, there are two of them. They're different truth values. But they're not merely different, they're exclusively different. True and false function like incompatible properties, such as square and triangular, not like compatible, merely different ones, such as square and red. Late in the game, we might consider relaxing the prohibition on anything being both true and false. But the original bivalent conception forbids overlap of extension between true and false propositions. Fine, sophisticated truthmaker semantics retains this basic structural feature via his exclusivity condition. Any fusion of truthmakers of a sentence with false makers of that same sentence must be an impossible state. That expresses his modal reading of the incompatibility of truth and falsity. On the pragmatic side, there's a corresponding normative prohibition on accepting and rejecting the same claim. One can never be entitled to such commitments. There's a deep connection between the shared exclusivity feature of truth values and doxastic attitudes, construed in the one case in alethic modal terms and in the other in deontic normative terms, on the one hand, and reason relations of incompatibility of claimables on the other. The exclusiveness or incompatibility of both paired truth values and paired doxastic attitudes is a symmetric relation among them. It doesn't privilege truth over falsity or acceptance over rejection. But there is also an important asymmetry between them. We can't systematically swap falsity for truth and truth for falsity while preserving the applicability of semantic theory. Truth and falsity are not just different and incompatible semantic properties. Truth is in some sense the good one, the one we want or prefer. And something analogous is true on the side of pragmatics. Practical attitudes of acceptance and its manifestation in speech acts of assertion have a certain pragmatic priority over attitudes of rejection manifested in speech acts of denial. While it might be more difficult to articulate just how acceptance is pragmatically privileged relative to rejection, Dummett has some good things to say about this, it is intelligible as a priority of taking true over taking false. The first claim I want to make here is that the sense in which truth is primus inter pares relative to falsity in the classical bivalent understanding of truth values is that it is what's preserved by good implications. The reason one cannot systematically swap falsity for truth while preserving a functioning semantic theory is that falsity preservation does not yield a usable notion of implication. As the exclusiveness of the true-false and accept-reject dichotomies is a matter of incompatibility, so the privileging of one pole of each is ultimately a matter of their relation to implication. This way of looking at things explains how the distinction among reason relations between incompatibility and implication can be seen to be a species at a higher level of the same genus of basic discursive bipolarity as the distinctions at the level of sentences between truth and falsity on the semantic side and between acceptance and rejection on the pragmatic side. Incompatibility relations capture the modally robust symmetric exclusion or repulsion aspect of the basic bipolarity, which is common to the semantic and pragmatic oppositions between true-false and accept-reject. In the classic setting, implication relations explain the non-symmetric privileging of some sentential truth values over others. Truth, or the designatedness of multi-values, is the property of sentences preserved by good implications. Further, I think this line of thought gives us reason to think of the version of the dichotomy at the level of reason relations as, in an important sense, more fundamental than the versions that show up at the sentential level. For this account articulates the metaconceptual relational features of bivalent truth values that explain their metaconceptual capacity to express important properties of sentences. We introduce the concept of reason relations of implication and incompatibility as normatively governing which doxastic commitments count as reasons for which others and which count as reasons against which others. In the first instance, these are reasons to accept and reasons to reject. forwarded in justificatory defenses of and critical challenges to doxastic commitments. I've claimed that we won't properly understand the semantic and pragmatic properties of sentences that exhibit the basic discursive bipolarity of true, false, and accept, reject, unless the story includes reason relations of implication and incompatibility. And in the book, we show that there's a robust bimodal isomorphism between pragmatics and semantics that also holds at the level of reason relations. Together, these considerations give us reason to look to reason relations in order to understand the truth-evaluable, acceptable, and rejectable contents that are expressed by declarative sentences, which are what stand to one another in the relations of implication and incompatibility that are amphibious between what's specified in the bilateral pragmatic and truth-makers semantic metavocabularies, each of which exhibits its own version of the basic discursive bipolarity. This is a version of semantic inferentialism. Because the very same reason relations can hold in both the pragmatic and semantic settings, we can consider what kind of thing stands in those relations just insofar as the reason relations are shared. This will be the rational or conceptual aspect of the propositions that can be specified in two quite different ways. Because they stand in reason relations, I'll call the relata rational propositions when they're specified in terms of their role in reason relations alone. Their functional roles, those very different kinds of items, can play with respect to the at least potentially shared implications and incompatibilities. We needn't go so far as to identify truth-evaluable sayables and claimables with those roles in reason relations in order to investigate the rational dimension of such propositional contents, in the sense of the aspect or dimension of content that consists in playing that role in reason relations. We can still call that specifically conceptual content. In the top-down order of explication that I'm pursuing, which appeals to relations of implication and incompatibility in order to understand the propositional contents expressed by declarative sentences, we face clarificatory demands concerning the nature of reason relations that traditional bottom-up orders of explication do not. In Fine's truth-maker semantics, for instance, the structure of consequence relations is determined by and inherited from the modal and mereological structure of propositions, just as in earlier views, consequence relations were read off from the truth conditions of the sentences that show up as premises and conclusions. What, we can ask, considerations specifiable at the level of reason relations put structural constraints on implications and incompatibilities? Well, I've mentioned two so far. To begin with, reason relations come in two flavors, corresponding pragmatically to reasons for and reasons against. Reasons entitling interlocutors to accept and reasons entitling interlocutors to reject doxastic commitments. And I've argued we should think of this bit of structure as the manifestation at the level of reason relations of the same basic discursive bipolarity that shows up in traditional semantics as the distinction between truth and falsity, and in bilateral pragmatics as the distinction between acceptance and rejection. But what further structural restrictions might the meta-theoretic role envisaged for reason relations impose on the consequence relation? We want to assume nothing about the structure of the bearers, sets of which stand in reason relations to each other. On our spare conception of a vocabulary, implication relations are just sets of pairs of sets of sentences, each such pair being thought of as pairing a set of premises and a set of conclusions that follow from those premises, in the sense of follows that's being represented. What, I'm asking, what considerations could be appealed to in imputing a structure to consequence relations as such? From the point of view of a top-down implication relations to sentential contents order of explication, it's perhaps surprising that the logistical bottom-up tradition has a well-defined, widely agreed upon answer to this question, even though that tradition is not at all pursuing the project that motivates me to ask the question here. A century or so ago, Tarski and Gensen, the founders respectively of the model theoretic and proof theoretic traditions in logic, put forward basically the same proposal for necessary and sufficient structural conditions for relations among sets of sentences to qualify as genuine consequence relations. Their official topic was specifically logical consequence relations. But unlike his, their characterization of the required structure did not appeal to the internal logical structure of the sentences that stand in those consequence relations. I'm contrasting them with Fine. Indeed, Tarski sometimes omits the qualification logical and refers to his topic just as consequence relations. Tarski's view is that what's essential about consequence relations is that they correspond to topological closure operators. In our terms, he takes a vocabulary to be a lexicon L of sentences and a two-place relation between sets of sentences, pairing each subset X in L with its consequence set, Cn of X, satisfying three conditions. Containment, CO, that X is always a subset of its consequences. Monotonicity, that if X is a subset of Y, then the consequences of X are a subset of the consequences of Y. And idempotence, CT, that the consequences of any set of sentences are just the consequences of that sentence. These are variants of the Kuratowski axioms for topological closure operators. It'll be helpful to think of these principles in other notations. We can write gamma with a snake turnstile and then A to say that the premise set gamma, a subset of the lexicon L, implies the sentence A. As I want to talk about it, the explicit content of the premise set gamma consists of sentences that are elements of the premise set, just the premises. The implicit content of the premise set gamma is, in a very literal sense, whatever it implies. That's what's literally implicit in it. Put in these terms, the structural principle of containment says that all of the explicit content of every premise set is also part of its implicit content. Monotonicity says that adding anything to the explicit content of a premise set never subtracts anything from its implicit content. And idempotence says that making implicit content explicit never adds any implicit content. Together, they guarantee that drawing consequences from a premise set is a cumulative enterprise that leads path independently to a single, stable, final conclusion set, the rational closure of the original premise set, the set of all its consequences. These are all principles concerning the structure of implication relations. They address only the role sentences play as premises and conclusions of implications, regardless of what internal structure those sentences might or might not have. The closure principles articulate a structure common to the consequence relations of traditional logics, paradigmatically classical, intuitionistic, and modal logics, and they hold of the reasoning used in mathematical proofs. Those virtues are sufficient to confer some plausibility on the claim that the topological closure conditions specify necessary and sufficient conditions for a binary relation between sets of sentences to qualify as a genuine consequence relation. There are at least two principled reasons that one might accept such a definition. First, one might take it that consequence just means, specifically, logical consequence. This is the claim that genuine reason relations are always at base logical reason relations, that implication is logical deducibility and incompatibility is logical inconsistency. Behind such a definition is logicism about reasons, the view that in the end, all good reasons, whether for or against, must always boil down to logically good reasons. The Tractatus is the purest example of such an account. I think not many contemporary philosophers would defend this sort of universal logicism about reasons, even as properly restricted to doxastic rather than practical reasons. A weaker fallback position is what could be called structural logicism about reasons. It acknowledges that some good implications might not be logically good, but insists that even material, non-logical consequence relations must share the topological closure structure of logical consequence relations, on pain of not qualifying as consequence relations, at least in the sense that has normative significance for reasoning practices. In spite of the considerable weight of authority and tradition behind treating topological closure structures as a necessary condition for genuine consequence relations, the stubborn fact is that outside of the artificial formal languages of logic and mathematics, a lot of actual reasoning conducted in natural languages is defeasible rather than monotonic. Premise set gamma can imply A, even though if we add further sentences to gamma, the result may no longer imply A. This sort of defeasibility of evidence, its status as merely probative rather than dispositive in support of a conclusion, is ubiquitous in practice, even in the most institutionalized contexts of reasoning, such as in law and medicine. Non-monotonicity is also a familiar feature of probabilistic reasoning, where new information can change the relevant reference class with respect to which frequencies are assessed. Nor do speakers cite defeasible reasons just for convenience, because it would be too tedious to include all the provisos and conditions needed to render the implication indefeasible. There might be no systematic characterization of all the necessary qualifications. Ceteris paribus clauses should be understood as explicitly acknowledging the existence, now turning a defeasible reason into an indefeasible one. A Latin phrase whose utterance could do that is called a magic spell. And although it's less commonly remarked, incompatibility relations are no less defeasible in general than implications. The view that defeasible reasons for or against must be elliptical for full reasons that are not defeasible is a consequence of commitment to a structural logicism that's contravened, I think, by our actual reasoning practices. The response of some philosophers to the empirical prevalence of non-monotonic, non-logical implications has been to develop non-monotonic logics. I think in the end that's a mistake, and not just when it's justified by commitment to an objectionable logicism or structural logicism about reasons in general. The proper task should be understood rather to be to construct a logic adequate to express non-monotonic implication and incompatibility relations. The distinction between the two enterprises is subtle but important. Wolf talked about this earlier in connection with Jeff Horty. In order to make it properly visible, I'll need to motivate logical expressivism. That's the claim that the expressive task distinctive of logical vocabulary as such is to make reason relations of implication and incompatibility explicit in the form of claimable propositional contents expressible by declarative sentences. That's where I'm heading. First, I want to argue that focusing on monotonicity is already making a kind of mistake by overlooking other structural conditions on reason relations that are actually deeper, more interesting, and more important. Monotonicity of implication principle. MO says that for any arbitrary good implication, gamma implies A, and any arbitrary further sentence B, gamma together with B also implies A. And that's guaranteed to be a good implication if gamma implies A is. If we take seriously the idea that monotonicity, MO, is too strong a constraint on rational consequence relations generally, there are accordingly two universal quantifiers that might be restricted. We can consider principles that only allow weakening of certain kinds of implications, but not all, and we can consider principles that allow weakening only with certain kinds of sentences, but not all. Containment, CO, is a restricted monotonicity principle of the first kind. It focuses on just one class of implications, those licensed by reflexivity, which says that all implications of the form A implies A are good. CO says that all implications of that form can be arbitrarily weakened by any set of additional premises whatsoever. In the idiom I've suggested, CO says that any implication is good whose conclusion, what the implication certifies as part of the implicit content of the premise set, is already part of the explicit content of the premise set, that is one of the premises. All those implications are good. That is an antecedently plausible constraint to put on the conception of following from, and as we'll see, it cuts at important joints. The principle called cautious monotonicity, CM, by contrast, quantifies over all good implications while restricting what can be added to the premise set by licensing only weakenings that add sentences meeting a special condition. That condition is defined relative to the original premise set. The plausible idea is that while there might be some sentences whose addition to a premise set infirms the implication of some of its consequences, it's at least safe to add to the premise set sentences that are already implied by it. Here's a Gensen-style sequent-calculus formulation of this rule, which should be read as saying that if all the implications above the horizontal line are good, then so is the implication below the line. So if gamma implies A and gamma implies B, then gamma together with B implies A. If some sentence B is already part of the implicit content of a premise set gamma, then adding it to gamma as an explicit part of the premise set doesn't subtract any implicit content. Anything that followed from gamma also follows from gamma together with any of its other consequences, since they're already implicitly contained in it. Cautious monotonicity brings into view an important operation on implications, for it involves comparing the consequences of two premise sets, gamma and gamma together with another sentence that's already part of its implicit content. In effect, we're looking at the effect of explicitation in the sense of making some of the implicit content of a premise set explicit by adding that consequence to the premise set. This is moving a sentence from the right-hand conclusion side of the turnstile to the left-hand premise side. Explicitation in this clear structural sense is a relation between implications, that is, a relation between reason relations. It's important because on the pragmatic side, it normatively governs the process of inferring. Understood as acknowledging, as an explicit or avowed commitment, something that one was only implicitly committed to in the sense that it was implied by one's other commitments. Doing this is a central, crucial form of rational inferential activity, extracting the rational consequences of one's beliefs. So it's worth thinking a bit about the relations between explicitation and structural restrictions on reason relations. And notice so far we don't care anything about what's inside the sentences, what logical structure or other structure they might have. In this connection, CM, cautious monotonicity, says that explicitation never loses implicit content. Anything implied by a premise set is also implied by that premise set, together with any of its other consequences. This principle has a dual, which says that explicitation never adds implicit content, that anything implied by a premise set, together with some of its consequences, is already implied by the premise set alone. This structural principle is cumulative transitivity, CT. We saw a version of this already in the Tarski, that says that if gamma together with B implies A and gamma implies B, then gamma already implies A by itself. That's just a sequent-calculus version of the Tarskian transitivity as idempotence closure principle, since it says that consequences of consequences are already themselves consequences of the original premise set. It too governs the paradigmatically rational pragmatic process or practice of inferring in the sense of acknowledging consequences of one's commitments. The connection to rational explicitation and the symmetric duality of CM and CT that consists in their just being rearrangements of the same three sequence are what I meant by suggesting that pairing monotonicity with CT is both less important and less natural than appeal to the dual explicitation principles, quite apart from the empirical observation that non-logical implications are not always monotonic. Although CM and CT do not require implication to be a topological closure relation, they do define a weaker but still significant kind of rational equilibrium. Since CM says that explicitation never subtracts consequences from a premise set, and CT says that explicitation never adds consequences to it, together they entail that explicitation is inconsequential, making the implicit consequential content of a set of premises explicit as further premises never changes the implicit content, what follows from those premises. All the premise sets that result from any given one, by adding some of the sentences it implies, have exactly the same consequence sets. In this sense, cautious monotonicity and cumulative transitivity define a structural condition on reason relations we can call explicitation closure. Consequence relations that are closed under explicitation form a natural kind. It includes the fully monotonic, topologically closed implication relations, but also many non-monotonic ones. Explicitation closed implication relations play a special role in the paradigmatically rational inferential process of discovering and acknowledging explicitly the implicit consequences of one's commitments, that is, what they imply. Well, we should ask then, are there any relations that deserve to be thought of as consequence relations that are not closed under explicitation? I think the answer is yes. Explicitation is not always inconsequential. Here's one very general, practical process governed by an implication relation where changing the status of a claimable from conclusion to premise is of considerable significance. Consider a database, say an experimental physics installation, such as a superconducting supercollider. All the observational data from the supercollider is put into a database, and an inference engine in the form of a scientific theory is then clamped on to the database to extract consequences of those observations according to the theory. Many of those consequences will themselves be sentences expressing observables. If observation qualifies one of those theoretically predicted consequences to be placed in the database of observations, moved from the conclusion side of the turnstile to the premise side, that experimental confirmation of the theory can be an event of great import. Confirming one prediction might well offer reasons for making further predictions and changing confidence in or even our endorsement of others, for the predictions need not in general all be compatible with one another. In this sort of context, explicitation, as changing the status of a sentence from expressing an implied conclusion to expressing a premise, has the significance of empirical confirmation of the theory used to make the prediction. Far from being inconsequential, this sort of explicitation is at the core of scientific practice and its constraint by empirical observation. Of course, not all consequence relations attach this sort of additional significance to the distinction between premises and conclusions. But the point is that they can, and when they do, CM and CT need not hold. At the least, we have good reason to want to make sense of consequence relations that are hyper-non-monotonic, in not even being cautiously monotonic or cumulatively transitive. Looking at the structure of implication relations from the vantage point of explicitation is considering the constraints that stem from relations among implications, for that's what explication is. We care about the explicitation relation because it normatively governs attempts to extract consequences from a set of commitments. An explicitation path from a premise set gamma to a sequence of supersets of gamma, each one resulting from the previous one by adding as a premise some consequence of the previous premise set. We're used to thinking of explicitation as inevitably leading to a foregone conclusion, the same one no matter what consequences we acknowledge first and which later. The rational closure of a set of premises gamma comprises all the consequences of gamma. But there is such a thing as the rational closure of a set of commitments only in the special case where CM and CT hold, so the consequence is explicitation closed. In hyper-non-monotonic cases, where CM and CT are not guaranteed to hold, explicitation paths can diverge. Which conclusions one can reach from the same base gamma depends on the order in which one extracts consequences from it. Some that are passed over early can become inaccessible later. This is rational hysteresis, or path dependence. The process of inferring, in the sense of following out an explicitation path, is, in an explicitation open rather than an explicitation closed setting, an essentially historical process that can lead far afield from its starting point. Now, people disagree about whether believing all the consequences of one's beliefs is an epistemic ideal. The usual objection is that it's impossible for us poor finite forked creatures to do that. The consequence set is too large, some of the conclusions are too distant, and ought implies can. But both parties to that dispute think that at least there's something definite to mean by all the consequences of one's beliefs. That's what they argue can or cannot and ought or ought not to be believed. My point is that whether it does make sense depends on the structure of the reason relations involved. And there's a specifiable boundary between consequence relations for which it does and consequence relations for which it does not, so much as makes sense. And that boundary is explicitation closure. I want to claim that even the most structurally relaxed of these kinds can serve the basic pragmatic function of determining reasons for and reasons against to serve in defenses and challenges of claimings, where a principal criterion of adequacy of doing that is underwriting the isomorphism of the truthmaker semantics at the level of what therefore display at least those credentials for being called reason relations. But I want to look more closely at two further metatheoretic offices that the concept of reason relations is called upon to carry out. For the pragmatic and semantic formal metavocabularies for talking about reason relations do set substantial, reasonably definite criteria of adequacy on conceptions of the structure that characterizes reason relations recognizable as such. Can we do logic with radically open structured relations of implication and incompatibility? Do hyper-non-monotonic reason relations allow the definition of a tractable notion of the propositional conceptual contents expressed by declarative sentences in virtue of the role those sentences play as premises and conclusions of implications and as standing in incompatibility relations without the traditional closure structures? And I hope to show that both these roles can be played by structurally open reason relations as well as structurally closed ones. Ulf has already showed you some of the semantic apparatus. Reason relations of any structure that can clear those substantial hurdles in logic and semantics will be able to play their role in pragmatics as normatively governing a minimal discursive practice of making, challenging, and defending claims. And those open reason relations, both topologically open and explicationally open, will suffice to correlate up to isomorphism the use of sentences described in such a pragmatics with a truthmaker modal mereological account of their meanings, as well as a more general and abstract implication space semantics. What might be called the reasons question in the philosophy of logic is how logic is related to reasons and reasoning. My first claim is that the beginning of wisdom in addressing that question is to learn from Harman's point that the relation of logic to reasoning practices is mediated by reasoning relations of implication and incompatibility. Earlier, I mentioned the logicist answer to that question, that reasons question, namely that all good reasons are at base logically good reasons. I've just been arguing against the weaker thesis of structural logicism, which maintains that all non-logical consequence relations must share at least the closure structure of logical consequence relations, on pain of not qualifying as relations of rational implication. Since logicism about reasons entails structural logicism, if there are structurally open reason relations, logicism can't offer a general answer to the reasons question. But if logic doesn't determine in general what implications and incompatibilities hold among logical, non-logical sentences, how is it related to those sometimes open structured reason relations? My second claim is that properly understood, the task of logic is not to determine non-logical reason relations, it is to express them. Put slightly more carefully, the expressive task that distinguishes logical vocabulary is making implication and incompatibility relations among sentences of a non-logical base vocabulary explicit in vocabularies that have been extended from those bases by the addition of the logical vocabulary. This general form of response to the reasons question is rational expressivism about logic. It's a kind of expressivism because it understands the defining task of logic to be a matter of what it makes it possible for its users to say, rather than, for instance, anything about what it makes it possible for them to prove. It's a rational expressivism because what's expressed is taken to be reason relations, rather than, for instance, some kind of attitude, as in traditional metaethical expressivism. In the book, Ulf and I sketch a pragmatic account of a minimal discursive practice in which participants use sentences to assert and deny claimables, which essentially involves rationally defending and challenging claimings with reasons for and against them. And those reasons for and against are in turn determined by reason relations of implication and incompatibility among the contents of the sentences. By doing what they do, such users of a base vocabulary accordingly practically acknowledge the reason relations that normatively govern their giving and asking for reasons. But they need not be able to say what sentences imply or are incompatible with each other. Logical vocabulary gives them the additional expressive power to do that. The idea is that the conditional, if A then B, says that A implies B. Adding negation makes if A then not B available to express the incompatibility of A and B. Logical vocabulary makes it possible to make reason relations explicit in the sense of sayable, assertable, and deniable, rationally challengeable and defensible. The defining expressive function of conditionals and negations is to codify reason relations in the form of rational propositions, that is, in the form of claimables that can themselves stand in reason relations of incompatibility and implication, both to sentences of the lexicon of the pre-logical base vocabulary and to other logically complex sentences formed from them. We can make this way of thinking about the expressive role of logic more precise by formulating it in terms of the simple relational structure I called vocabularies. As I'm using the term, a vocabulary is an ordered pair of a lexicon and a set of reason relations on that lexicon. The lexicon is just a set of sentences, and the reason relations can be thought of as a set of good implications. For technical reasons, we can think of implications as pairs of a premise set of sentences and a conclusion set of sentences, and we can encode incompatibilities in that way. On the expressivist account, a logic is a means to extend a base vocabulary to a supervocabulary of it, in the sense of a vocabulary whose lexicon is a superset of the base lexicon and whose reason relations contain those of the base vocabulary. To introduce logical locutions into a language, one must define a function that first expands the lexicon of any base vocabulary by adding the new sentences that are logical compounds of old ones. We know how to do that. And then computes the reason relations of the newly expanded lexicon from the reason relations that govern the use of the base lexicon. So the question is, how can you do that? How can you compute the implications and incompatibilities that govern the extended vocabulary that includes all the conditionals, disjunctions, conjunctions, and negations that you can form iteratively from the base vocabulary? You can see how the logically extended lexicon can be extended. How do you extend the reason relations? An ideal metavocabulary for specifying those relations is Gerhard Gensen's sequent-calculus that he introduced in the founding document of proof theory. Its basic idea is to treat reason relations, specifically implications, as mathematical objects called sequents. It then operates on those objects and permits the formulation of rules relating them. In short, the sequent calculus is an expressively powerful metavocabulary for specifying relations among reason relations. Sequent rules always have the meta-inferential form: if these sequents codifying implications are good, then so are these others. The input sequence are written above a horizontal line called an inference line, with the output sequence written below it. Meta-inferential rules are of two kinds, structural and operational. The structural rules, kind I've been talking about so far, don't depend on anything about the lexical items involved in the sequence, except their identity or non-identity to one another. For instance, we can formulate monotonicity involving the meta-inference line of the sequent calculus. If the premise set gamma implies the conclusion set delta, then so does gamma together with any arbitrary sentence A of the lexicon. The operational rules include relations among implications that contribute to the meanings of logical locutions. One that's important to my story is the right rule for the conditional, which captures its expressive rule as making implications explicit in the form of sentences of the logically extended object language. This is the deduction detachment principle on your handout. Here, the double horizontal line means the meta-inference is being stipulated to hold in both directions. You can go up as well as down. Rational expressivism about logic, the view that what distinguishes and demarcates logical locutions as such is their expressive role in making reason relations of implication and incompatibility propositionally explicit, both puts constraints on the admissible ways of computing the reason relations of a logically extended vocabulary from the reason relations of a non-logical base vocabulary, and sets criteria or norms desiderata for assessment of the adequacy of particular sets of metalogical sequent rules. First, the logically extended vocabulary must be elaborated from the base vocabulary, in the sense that both the lexicon and the reason relations of the extended vocabulary must be computed from those of the base vocabulary. Second, the logically complex sentences of the extended vocabulary must explicate the reason relations of the base vocabulary, as well as those of the logically extended vocabulary. A lot more will need to be said to articulate and give a clear sense to this criterion of adequacy. But we already have the paradigm of the deduction detachment rule that shows the sense in which the conditional makes it possible to form sentences that say, in the extended object language, that a particular implication holds. At this point, I just want to observe that the explication condition entails a conservativeness requirement on the elaboration condition. Explicating reason relations, in the sense of making them explicit as the conceptual contents of sentences that themselves imply and are incompatible with others, requires that doing so doesn't change what one's expressing. To achieve that, it's necessary and sufficient to require that in the logically extended vocabulary, all the implications and incompatibilities that involve only lexical items from the base vocabulary are just the same as they are in the base vocabulary from which it's elaborated. I'll say that a vocabulary that's conservatively elaborated from and explicative of some base vocabulary is LX for that vocabulary. One measure of the rational expressive power of a logic, understood now as specified in a sequent-calculus meta-inferential language, is then determined by the variety of base vocabularies for which it is LX, that is, from which sequent rules conservatively elaborated and whose reasons relation it explicates. The structural closure conditions on implication relations I talked about earlier provide an appropriate scale on which to measure expressive power so understood. Some logics, as specified by meta-inferential sequent rules, fail to define conservative extensions of any non-monotonic or non-transitive base consequence relation. That's true of Genson's canonical sequence specification of classical logic, his system LK. And even logics that could elaborate and explicate topologically open logics, which fail to satisfy the monotonicity principle MO, might well fail to be LX for logics that are not even explicitation closed. The expressive ideal along this dimension is a logic that's universally LX. LX for any and all base vocabularies, regardless of the structure of their reason relations. And I'm happy to be in a position to share with you, it's not news if you've looked at the book, that there is such a universally LX logic. We call it non-monotonic multisuccedent logic, or NMMS for short. And I put one set of rules for it on your handout, but they actually don't matter at all to the points that I'm making. This logic has three remarkable properties. The first is it's expressively complete in an unprecedentedly strong sense. Our collaborator Dan Kaplan showed how to associate each sequent or set of sequents, whose premise set and conclusion set consist of logically complex sentences, to associate that with a set of sequents in the base vocabulary, which relate only logically atomic sentences that occur in them, such that those sequences in the logical supervocabulary hold in all and only the NMMS elaborations of bases in which just those atomic sequences hold. In this clear sense, the logically complex sequence say that the corresponding logically atomic sequence hold. For their derivable, the logically complex ones, just in case those reason relations hold in the base vocabulary. Fixing the lexicon of the base vocabularies, we can compute for any set of atomic sequence which logically complex sequence say that just those sequence hold, and for any set of sequence relating logically complex sentences, we can compute just which base sequence they say hold. This is the precise version of the explicational dimension of LXness for any relations of implication and incompatibility that atomic sentences can stand in. NMMS permits the formulation of a single sequent in the logically elaborated supervocabulary that expresses just those ground-level reason relations in the sense that that sequent is derivable just in case those reasons hold in the base. Reason relations hold in the base. This expressive completeness result is a more powerful version of the way that in the two-valued semantics for classical logic, truth tables let us go back and forth between the values of logically atomic sentences and those of logically complex ones. It applies to assessments of candidate implications as good or bad, rather than assessments of sentences are true or false. It's more powerful in that every finite set of atomic implications in the base vocabulary is represented by a single sequent in the logically extended consequence relation, and every implication in the logically extended consequence relation represents a unique set of atomic implications. The second remarkable property of NMMS is that it's fully tolerant of open-structured or radically substructural base vocabularies. This feature has to do both with the elaboration dimension of LXness and the explication dimension. NMMS conservatively extends logically atomic base vocabularies that are non-monotonic and non-transitive, those in which cautious monotonicity fails, and even those for which containment fails, and its conditional and negated sentences codify the reason relations of all such substructural reason relations. This is a substantial achievement because it's easy for meta-inferential rules for connectives to enforce global structure, for instance, monotonicity. An obvious example is a left rule for conjunction that says that if, in some context gamma, a premise A implies something, then that same conclusion follows from the conjunction A and B, which rules out the addition of further premises infirming or defeating an implication. Within very wide limits, the full expressive completeness result still holds for the elaboration of substructural base vocabularies by NMMS. So NMMS is provably universally LX. It elaborates any base vocabulary, no matter its structure, and does so in a way that's expressively complete, providing logical codifications of arbitrary collections of atomic reason relations. The third remarkable property of NMMS, remarkable I think particularly in view of the first two, the expressive completeness and the universality, is that it's essentially just classical logic. Understanding the sense in which NMMS is classical logic and also what nevertheless distinguishes them, sheds significant light on the interrelations between the topologically and explicitationally open structure of material non-logical reason relations and the expressive task distinctive of logical locutions. The first data point in understanding the intimate relations between classical logic and NMMS is this. In the fully topologically closed setting defined by Genson's full set of structural rules, NMMS yields exactly the same logically valid sequences as Genson's sequent-calculus version of classical logic, LK. In this sense, there are many equivalent sequent-calculus versions of classical logic, different ways of defining the logical connectives that yield the same logically good sequence. As long as we impose the full battery of topological closure structural principles. But as soon as we relax the structural requirement of topological closure, those hitherto equivalent formulations come apart. Differences among them that don't matter in closed structures turn out to make a huge difference in open structured settings. And we've tried to pick the best one of those. The second data point in understanding the intimate relations between classical logic and NMMS is that NMMS is supraclassical when applied to any base vocabularies that include all instances of containment, CO, regardless of what other structural principles do or do not hold. That is, all classically valid implications and incompatibilities, inconsistencies, are included in the NMMS elaboration of every base vocabulary that includes as good all sequence where some premise is included in the conclusion set. This takes us a step beyond the first point, that if those CO instances are the only good implications in the base vocabulary, then NMMS validates all and only classically valid reason relations. So, out of all the variant ways of introducing the connectives of classical logic in the sequent calculus, NMMS is one that not only degrades gracefully, but continues to work fully, have its full expressive power, when we move from structurally closed to topologically and even explicitationally open settings. In those settings, NMMS still elaborates base vocabularies conservatively. It's supraclassical if those base vocabularies satisfy containment, and yields exactly the classically valid implications and incompatibilities if it's applied to base vocabularies, all of whose implications are instances of containment. In all those open structured and closed settings, it remains expressively complete in the very strong Kaplan sense. For every set of atomic base sequence, there's a unique logically complex sequent that's derivable just in case the base vocabulary to which it's applied contains those atomic sequence, and vice versa. So, my aim here has been to demonstrate the benefits from a change of perspective in thinking about logic. What matters most about logic, any logic, is not its theorems or even its consequence or inconsistency relation. That is, the logical reason relations the logic gives rise to and enforces. What matters most is the expressive power it affords to make explicit a variety of material reason relations of non-logical vocabularies. In our regimentation, particular implications and incompatibilities defined on non-logical lexicons are codified as logically complex sentences in extensions of those vocabularies, whose reason relations are defined by meta-inferential rules in a sequent-calculus metavocabulary. The right logic can make explicit the reason relations of any and every base vocabulary, even those with the most minimal structure. And the practical expressive capacities afforded by logical connectives, even of less expressively powerful logics, are transformative for language users. For we can compare two linguistic communities, one of which asserts and denies and challenges and defends the resulting commitments according to the reason relations of a non-logical base vocabulary, with another community that does the same with the lexicon and reason relations of the logically extended vocabulary computed from that base. The first group of speakers is rational. They can not just respond differentially to things, but can respond by making claims and judgments, and they can give and assess reasons for and against their claims and objections. But they can only disagree about and critically assess the credentials of Doxastic commitments manifestable as assertions or denials. They can't make claims about or assess the credentials of the implications and incompatibilities they implicitly appeal to in their reasoning. They're rational, but not self-consciously rational. What they're missing is logic, and logic is at base an organ of rational self-consciousness. What confers that power is the full logically extended consequence and incompatibility relations, precisely because they relate logically complex sentences that do not codify reason relations that hold in virtue of logic alone. Conditionals such as, if it's raining, then the streets will be wet. The purely logical reason relations articulate the contents of the logical locutions, and that's important. But the logically extended vocabulary articulates the contents of the non-logical locutions of the base vocabulary, and that's more important. We can define what it is for some implications and incompatibilities in the logically extended supervocabulary of a base vocabulary to hold in virtue of logic alone as the ones that hold in the logical extension of every base vocabulary that meets some minimal structural conditions. So all the sequence of classical logic hold in NMMS extensions of bases in which all instances of CO hold. Also, the implications and incompatibilities that hold in the NMMS extension of a base vocabulary whose reason relations consist just of the instances of CO are exactly those of classical logic. NMMS has been carefully sculpted to extend the open structured material consequence relations conservatively, not imposing monotonicity or transitivity on material bases that are not monotonic or transitive. Indeed, even hyper-non-monotonic, explicitationally open bases where even cautious monotonicity fails. But the astonishing fact is that the purely logical part of any NMMS extended base vocabulary is guaranteed to be fully structural and even topologically closed. The logic is monotonic and transitive, so idempotent. In this strict and literal sense, NMMS is not a non-monotonic logic. It's a monotonic, structurally classical logic for codifying non-monotonic consequence relations, and non-monotonic incompatibility relations, and non-transitive consequence relations, even ones for which CM fails, and so on. Looking back from the point of view of rational expressivism about logic, the thesis that the expressive role that distinguishes specifically logical vocabulary is making reason relations explicit, the logical tradition of the past 100 years or so can be seen to have made two large mistakes. The first is a version of the one made by the drunk who looks for his keys under the street lamp rather than across the road where he dropped them because the light's better there. In this application of the metaphor, the bright light is the clarity, perspicuity, and tractability of classical logic under the traditional bivalent semantic interpretation. The role of the keys is played by the codification of reason relations. Logicism about reasons is the view that reason relations must be codifiable by that spectacularly well-behaved classical logic. The second mistake is subtler. When logicians did take seriously the existence of substructural or open-structured reason relations, the form their efforts to codify them took was logic whose own reason relations were substructural. For if reason relations are at base logical reason relations, as logicism claims, then there must be open-structured logical reason relations behind those open-structured material reason relations. That is, the motivation for non-monotonic logic non-trivially includes keeping logicism even while giving up structural logicism. Expressivists do it the other way around, for we've discovered we can split the difference by codifying radically open-structured reason relations with a logic, NMMS, whose own logical implication and incompatibility relations are topologically closed, just like those of classical logic. Further, that universally LX logic is supraclassical and collapses to classical logic when applied to a flat prior, in the sense of a base vocabulary consisting only of CO instances. One of our central claims is that the minimal structural conditions on rational relations of consequence and incompatibility are much weaker than has traditionally been supposed. Today, I address the question of whether, to what extent, and in what sense, radically substructural reason relations whether merely topologically open or also explicitationally open, deserve to be thought of as genuine reason relations of implication and incompatibility. And I've shown that they pass at least one test that's crucial for logical expressivists. They can be codified completely and adequately by a well-behaved logical vocabulary, indeed by what is in several real and important senses just classical logical vocabulary. In the book, Ulf and I go on to investigate what sort of conception of rational propositional content results from considering the role declarative sentences play in radically open structured reason relations. To that end, we show how a full-blown implication space formal semantics, incorporating a tractable concept of proposition, can be elaborated just from vocabularies in the spare technical sense in which I've been using the term, a lexicon together with a set of pairs of sets of lexical items meeting the most minimal of conditions. The first criterion of adequacy that semantics satisfies is that it provides a sound and complete semantics for the universally LX logic NMMS. It turns out that that result can be generalized to many other logics as well. Our ultimate interest, though, is in what expressivist logics and implication space semantics can teach us about the relations between meaning or propositional content and reason relations. Thank you.
Much. I'm gonna ask the room if there is some questions. So please raise your hand if you have questions about what Professor Brandom just said or about the book, generally speaking, or anything. Yeah, we're all tired, but thank you.
Hi there. Hi, Bob. Thank you. Thanks for the book. So a question about some of the claims you were making at the end there. I'm not sure I've understood you right, but it's the idea that although we have a system that is kind of compatible with non-monotonic reason relations, essentially the logical part of it is just classical logic. And as I've understood the formal kind of result here, it's when we take the base relation to be just the instances of containment, we just get classical logic. We get a sequence system for classical logic. And I think the step I'm not seeing is why, when you make the claim about the logic here just being classical logic, why are we understanding as, logic? Why are we lining up what we mean by logic with a turnstile that obeys all instances of containment? Why aren't all the turnstile relationships we've got classifiable as logic?
So the implications that hold in the logically extended vocabulary, some of them are quite specific products of the base that we applied it to. You only get these implication relations among logically complex sentences if the base has these certain material, non-logical consequences in them. What I'm calling the purely logical sequence in the logically extended language are the ones that hold just in virtue of the rules that we use to introduce the logical connectives. That is, that hold no matter what the base consequence relation is. So for any particular base, when you extend it, only some of the good implications, good sequence holding between logically complex sentences, only some of them will hold in virtue of logic alone. Some of them will be expressing particular features of the logical base. Those are the ones that the Kaplan expressive completeness result lets us compute. So we can say, oh, the fact that these sequence hold among logically complex sentences, even though they're not logically so, these sequence don't hold in virtue of logical alone, says that these particular sequence hold in the base vocabulary. So the key thing is to separate among the sequence that hold in the logically extended vocabulary, the ones that hold because they're reflecting some particular features of the base, and the ones that hold just because the base either includes all the instances of CO, so all the classical ones will hold, or otherwise. Ulf, you want to say something?
If I may, Bob, I mean, it's your talk, so I shouldn't really be answering. But after all, we also wrote the book together, so I feel like this is in some sense also a question that I could speak to. Because one thing that you didn't mention was the notion of logical form. And I think it would be a very traditional way to say, well, what I mean by logic is what arguments are good in virtue of their logical form. So we could understand Mark's question as why should we line up the notion of logical form with the bases that are just the CO instances. And I think this can be separated into two questions, namely, the things that are true merely in virtue of the sequent rules. Now, the thing is, if we just stop there, we actually don't have anything because you don't have any initial sequence. In order to make use of that, you need some initial sequence. And then the question is, which are the initial sequence that you feel happy about, as we're saying, belong to logical form in some extended sense of logical form. And the two options that seem most natural are either just the instances of plain reflexivity or the ones with weakening absorbs.
Yeah, I suppose a more succinct way of putting the question is a lot of heavy lifting is done by containment and in the definition of logic or your notion of logic. And I slight worry that an awful lot is being done by that.
Oh, okay, right. A lot is being done there. Gensen, of course, defined his logic as what you could get just from instances of reflexivity. A implies A. We're denying all these strong monotonicity principles, monotonicity itself, and even cautious monotonicity. It turns out that to do anything very interesting, you need you need to allow some sort of weakening principle. Containment is the sort of minimal weakening of RE. It says, well, you can weaken instances of reflexivity that will give you. And that's sufficient for us to do all this powerful logic, that weakening principle. So yes, a lot of weight is being put on it. That's sort of the minimal weakening principle. I'd be happy to do without it. Actually, the logic degrades rather gracefully with that as far as codifying things is concerned, but the logic goes away.
Thank you.
Sorry to insert myself again, but
Please do.
obviously I also have views about. But I think one thing that we should add, Bob, to what you just said is that we do have things that don't in the book. We have a version of linear logic. We also have a version of. We don't say that, but it's basically a version of a relevance logic that is somewhere. Don't worry about this too much. But so what you get, I think, is when you restrict yourself to just plain reflexivity without CO, if you want to get something nice, usually what you have to do is you have to tweak the connective rules a bit. So there's a bit of a trade-off. You rely more heavily on CO, and then you get the connective rules that we like. Or you're willing to tweak the connective rules a bit more to go into the direction, for example, of a linear logic. Which we don't like as much for certain philosophical reasons. But then you have the option of lightening up on the CO and going to just plain reflexivity, which I think in the way we presented in the book, but we should allow that as an option, even though we have, as it were, a view which of these things is preferable. That's, I think, as far as the logic is concerned in the book, we can say, well, if you want to go that way, then sure.
Other questions for now?
Yes, thank you. I have a question. It's about when in the book, it's about the book. When you talk about rational hysteresis, there is a path dependency of the consequences. And so you acknowledge at this moment that there is a choice that enter into the stage and that determines the truth of a perspective. And my question is about when you define your what is a vocabulary, you say that it's a set of sentences and implication or incompatibilities relation, and then you say that you have equivalences between sentences, and you take the example of I don't know anymore a sentence of Wittgenstein in English and in German, and you say that they are the same. And my question is, don't you think that when we say that two sentences are the same, there is not a choice that enter into the stage? And so my question is also, don't you think that it's possible to have a broader understanding of what pragmatics is? I mean, it seems to me that when you talk pragmatics, you understand the use of sentences or of language, but it seems to me that behind the use of language, there is a kind of set of choices or actions that are not action with language, but actions that bring language as something that we use. I'm not sure that I'm clear, but and I have a last question, which is in relation with this. It seems to me that you say that truth is a specific concept of semantics, and so that pragmatics needs the concept of truth that it takes from semantics. And I wonder whether it's not possible to make use of a specific pragmatist concept of truth, taking the form of maybe in the dialogical logic of strategies. Is it a choice that you made not to consider a specifically pragmatic form of truth that is a strategist? So sorry for the long question.
Okay. I mean, I am, of course, very concerned with what the pre-rational practical capacities are that have to be recruited and deployed so as to add up to a specifically discursive practice. You know, that's pragmatism is worrying about the knowing how that underlies knowing that. And though the book gives short shrift to this, we do start off with an account of the practices of making claims, challenging, defending them, and so on, in terms of which we can understand relations as reason relations, relations of being a reason for and being a reason against. And indeed, officially, we're either giving a pragmatics first order of explanation or entirely even-handed about this. My point early in my remarks today was to think at the level of reason relations rather than of properties of sentences, such as truth or being accepted by people. Now, another set of doings is involved once you're in the game of giving and asking for reasons. And before we've got any logic on board, this is part of reasoning, where one is implicitly committed to something in that it follows from the commitments one has explicitly acknowledged. But one hasn't explicitly acknowledged it yet. And I described one important thing to mean by inference, one important species of inference is precisely explicitly acknowledging explicitly accepting as one of one's premises something that was only implicit in one's previous commitments in the literal sense of implied by it. That's explicitation. And the fact that if the reason relations aren't closed in the explicitational sense, never mind in the topological sense, then where you can get to by the paradigmatically rational inferential process of making explicit commitments that were already implicit, where you can get to depends on the order in which you adopt them. And indeed, taking simultaneously all the consequences of my current commitments is just one choice that you could make. It gets you to one place, but not necessarily to the place you would get to if you had done it in an order. And that incorporates the contingencies of which of the consequences of your commitments you acknowledge first. That contingency gets incorporated in what is rationally accessible from where you started. This is the fundamental structural historical character of exercises of rationality in this classical sense of just acknowledging what's implied by what the consequences are of your current beliefs. That's an essentially historical process that incorporates the contingencies of the particular choices that one makes, or anyway, the order in which one actually acknowledges these things. Reason will be essentially historical anytime the reason relations are not explicitationally closed. And that, I think, is an important lesson of this perspective on reasoning before we talk about logic.
I have a little question before the other ones. So when you mentioned the cautious monotonicity and cumulative transitivity, you make this argument using the example of the Higgs boson that was already contained within the theory, so within the set of premises, so within, let's say, a standard model of particles. And when we actually observe the Higgs boson and we add it to our set of premises, then it can transform the consequential value of this premise set, right? But one thing I'm not sure I understand properly is whether the observation by the super collider of the Higgs boson is contained in the same manner as the prediction of the observation is. So I feel like it seems that it kind of violates even the containment requirement of logical consequence, because we can say, okay, the prediction of the Higgs boson is already contained in the theory, but when it comes to the actual observation of it, it seems that it's a different thing that we add from another place in the space of this, what the sequence represents, right?
Okay, I feel your pain. I hear the issue. I'm thinking about this very general species of consequence, where one has a database. It needn't just be observations. It could be what you believe is in the inventory, whatever your database is, that you then clamp on an inference engine, a consequence relation that you're going to use to extract consequences, answer questions from the database, and so on. And clamping on different inference engines is going to get you different consequences from the same set of premises. One important sort of inference engine is a theory that, when you attach it to a body of observations, but also includes other theoretical claims belonging to other theories, lets you extract consequences from it. And so I'm imagining that in the database, we don't have the claim there's a Higgs boson measured at this point, or even at any point. We have observations about other things, and the theory tells us that there are Higgs bosons, and if there are Higgs bosons, then from these observational data, this conclusion follows that you should get a particular reading if you do this experiment. Now, the database didn't have this result in it. That was only at most implicit in these observations according to the theory. That is, given what's implied by what's in the database according to the theory you clamped on as the inference engine. So now this observation is made. That qualifies it. We can put it into the database. If explicitation, taking something that was only implied and actually adding it to our explicit premises, if that were inconsequential, then that should make no difference. And of course, it does make a difference. Now, that's the theory and observation. That's a special case, but in general, if you have the situation of a database with an inference engine clamped onto it, that example just underlies the point that the inference engine might let you draw conclusions such that if you added them to the database, that very theory would draw different consequences than it would if you hadn't added that consequence to it. That sort of inference engine is not incoherent. It can be a perfectly good consequence relation, even though it has this feature that explicitation is not inconsequential. And of course, I think the consequence relations that we live our lives with are like that, and that we're just looking at particular formal cases where it's clear.
Yeah, we don't. I don't know if we should end in an hour as it was planned. Maybe if we all tired, we can end up a bit earlier, like at 6 p.m. Maybe that would be wise, especially for those who traveled a lot. But yeah, like feel free if you have any questions to ask them. It's a luck to have the chance to have Bob to answer them. So yeah.
Yes, thank you very much for the book and everything. I remember that I think more than 30 years ago you wrote that logic was the organ of semantic self-consciousness, and now this claim has been made explicit. So thank you for that. But my question is, what remains to be done, both in terms of developing inferentialism, and also in terms of your next work? What's next in a way?
Well, there's a lot we don't understand. Ulf talked this morning about extending to the first order case. We absolutely want to understand that, and I think great things will come from that. That's extending the top-down order of explication that I invoked in the beginning, that starts with the reason relations of implication and incompatibility, moves down to attribute semantic content to sentences. Well, now we want to attribute semantic content to singular terms and predicates. That's going to give us an understanding of objects, properties, and the generalizations of the notions of object and property that you get in these substructural cases. And I think there's wonderful things to be discovered there. There's another dimension of rational expressivism that we talk about a little bit in the book, but I didn't mention today. And that is where structural feature, where you introduce logical vocabulary not to codify particular reason relations, but precisely to codify structural features of those reason relations. So while we conceive material-based vocabularies, non-logical reason relations as being, in general, not only not monotonic, but not in general satisfying CM or CT. Still, there are going to be some monotonic implications, some cases where CM and CT hold, some regions within the base consequence relation that are structural, even though the structural principles don't hold everywhere. So, for instance, there certainly are monotonic implications. The implications of logic and mathematics are like that. Wouldn't it be nice to introduce an operator that made explicit the regions of the base vocabulary where these structural principles hold? And we can do that for monotonicity. Monotonicity has a natural interpretation in the sequent-calculus form where a particular implication is persistent. That is, not only does it hold, but it holds no matter what else you throw in to the premise set. And you can say in that case that it's not just the case that gamma implies A, but you can mark the fact that gamma together with anything else implies A by putting a box in front of A. It doesn't just imply A, it implies necessarily A. That is, in all circumstances, all additional premises that you could add will not infirm it. And we have a well-behaved treatment of that monotonicity box. It would be wonderful to use the apparatus of the implication space semantics to be able to give a treatment of subjunctive conditionals that didn't go through using modal operators like this persistence box that I'm talking about. Our conditional is intentional with an S, but a theory of subjunctive conditionals that's guided by the notion of the fundamental semantic phenomenon articulating the content of a sentence being the range of subjunctive robustness of various implications in which it plays the role of a premise or a conclusion. That's something we've only dipped our toes into. So I see the different conceptual moves that we've made in the book as opening up, a whole promised land that I don't expect to live to enter. But I will be excited to see what we can do with it next.
Thank you.
Yes, thank you. It's a very vague question, both to you and to Ulf, about the incompatibility relation. You say in the book that there are two relations, implication and incompatibility. But then when you model it, it's the standard way saying that P and Q are incompatible if you have a pair PQ and the pair of the set PQ and the void. And I don't know why, but that doesn't please me a lot. I don't know if you had any hesitation about modeling incompatibility like that, because for if P is a reason against Q, it's not natural to say that P and Q implies a void, because of containment, the pair PQ and P holds. But it doesn't make any sense, because if P is a reasons against Q, then I shouldn't be able to write PQ, P hold, that doesn't make sense. So that's my little bit of worry. It's not major, but I wondered if you had thought about that.
Well, I mean, I have a bad conscience about, on the one hand, arguing that people have often treated incompatibility as an afterthought, as a sort of second class reason relation, when I really want to see them as on a par, and so not see logic, even read very broadly, just as a study of consequence, but as a study of reason relations that must also include incompatibility. What I have a bad conscience about is combining that claim with using this technical trick that's familiar from the multisuccedent sequent calculus of representing incompatibilities by empty right sides of implications. I mean, I became persuaded that these were not actually incompatible. We can start with using a different symbol for incompatibility, use the pound symbol, and we give a, I think, interesting pragmatic Dutch book argument due to Ryan Simonelli, one of our colleagues in the role group, to argue that incompatibility as a reason relation must be treated as a symmetric relation on pain of it's not functioning pragmatically in the way that it needs to function. That's one thing that you might find objectionable as built into the notation of treating the set of premises as incoherent. I think is the term. The set is incoherent if there's an empty right side. Remember that okay, so I think that's in fact the fact that we're building in the symmetric character of incompatibility by in effect just using the property of a set being incoherent, let's say. But now remember, we're doing this in a non-monotonic setting. So from the fact that this set is incoherent, it doesn't follow that its supersets are incoherent. Also, from the fact that this set implies the null set, it doesn't follow that it doesn't also imply P. Indeed, it implies all of its elements. That's part of the sort of messiness of non-monotonic implication relations. So I convinced myself that we were not, in fact, giving up any philosophical ground by using this convenient notational technique. Ulf?
Does that work? Yes, it works. So one thing that I want to add there is that I think, so while it might has drawbacks, and I hear your worries, there's also the question what alternatives there are. And I think one alternative is, for example, to say, well, this is no good because, I mean, if we forget about the non-monotonicity for a while, for example, one thing that looks bad about it is that you might think, well, really what's incoherent is just one of these elements in the set. And just because the other one doesn't overrule that, shouldn't mean that, you blame the bigger set for that. Like, what does this innocent element that is not really contributing anything to the incoherence, why do you blame that one? But one worry I think we have, Bob and I think we both were influenced by Dan on this and in his dissertation, is that for this to work, so there are two ways to think about this, and this applies both to implication and to incoherence, actually. You can think, well, I want to explain why a set is incoherent or why a set implies something by attributing roles to the individual sentences so that I can, as it were, add them up, that I can weigh the reasons for and against in some sense, where that weighing, as it were, is the weights are what determines the weight of the overall thing, you know, of the whole set. And then what you have to do to make this work, I think, is what people in the reasons literature often do. You have not only reasons, you have attenuators, enablers, disablers. You know, you have all these different roles where you say, well, this is not a reason, but it enables this other thing to be a reason, or it disables that other thing to be a reason, or it intensifies it, or it diminuates it, or, you know, all these kinds of things. And I think what Bob and I think is that this is the wrong way to think about it. We want to explain, as it were, these notions of enabling and disabling, insofar as we think that they make sense, rather from the global perspective of what these things do in the reason relation. As it were, take the reason relation as the whole thing to be primitive, and then explain all these notions about the weighing, as it were, of things in terms of that. But when you then apply that to the incoherence case, I think you have to say, well, you know, as it were, we first have to get the incoherence relation on the table before we can, you know, start to think about what the different roles that things play in this, you know, the different elements in an incoherence set, for example, play in creating the incoherence. This is a part of the top-down strategy, I think. So while it has drawbacks, I think it has the advantage of having a pretty clean top-down strategy, which you then need to exploit, but is where it doesn't have all the messiness of trying to come up with all these different roles that things can play. That's Bob, is that fair? Is this a...
My question is about in the sequent calculus formulation, it's clear that some rules are multiplicative style, some other one are additive style one. And so I guess, as far as I understood, all the stuff that this is linked to the idea to maximize the reversibility properties. So could you explain why if there are other reasons to make such choice among the rules?
Well, I just want to acknowledge that, yes, to get the expressive power that's driving this, we need to mix and match additive and multiplicative rules. Some of them have additive left rules and multiplicative right rules in the linear logic sense. Of course, we're not proving cut eliminability at the end of the day, because we're not imposing that structural principle. That's the main thing that you lose by mixing and matching these principles. But at least for me, the details of how they have to be mixed and matched so as not to use the left conjunction rule or the right disjunction rule that build in monotonicity, just as one example. I don't have a philosophical rationale for that. That's what's required, not to build in the structure that we don't want to build in. And the rules we have are tractable. You know, the logic works. Indeed, we have the sound and complete implication space semantics for it. So that's a blemish we learn to overlook, or learn that we took those notions to be too determinative of what one could go on to do. But let me defer to Ulf, who's the one who actually made this work on this question.
Yeah. So obviously, this mixing looks like something that is undesirable from certain perspectives. On the other hand, it seems to me that sorry. Let me start over with just directly answering a question: why the invertibility is so important. one answer is, if you have these rules be invertible, it's obvious that from one sequent, do a proof search on that, and you get a unique set of base sequence, right? You get a unique set of leaves. And that means that you can read the sequent as expressing this part of the base. Whereas if you have non-invertible sequent rules, you end up with a disjunction, basically, right? So what you're expressing is a disjunction of base sequence rather than a unique set of base sequence. And if what you think, if you think it's important for a sequent to make explicit something about the base, it looks more direct and less cumbersome to ensure the invertibility in this way, right? It's where the relation between the complex sequence and the base sequence is much more straightforward. It's where just conjunction, no disjunctions involved there, and we think that is desirable. That leads to we think of that as part of the making explicit of the base sequence. That's one aspect of that. The other is that if you have a additive left rule, for example, for conjunction, this is what Bob said about building in monotonicity, right? You say, if you're a linear logician, you think that this doesn't build in monotonicity because you think you're only weakening inside the conjunction. But to me, it looks like that doesn't track anything that I can, see as concerning the worry about defeasibility that I have. It might, lighten up worries about relevance, because you might say, well, the whole sentence is relevant because it has a relevant part. But if you'd tell me, for example, oh, Tweety is a bird, so Tweety can fly, that's a good inference. But Tweety is a bird, Tweety is a penguin, so Tweety can fly, that's not a good inference. But Tweety is a bird and Tweety is a penguin. Now the consequence Tweety can fly follows again. Then I'm thinking, that doesn't sound reasonable to me. So I think this conjunction left rule is out. But then if you add a multiplicative conjunction right rule to this, you basically get the same, especially if you have CO around, you can mimic, you can undermine the defeasibility in a pretty straightforward way. Again, right? You just take this here. So I think at an intuitive level, it's clear that you get defeasibility counterexamples. So you can't really validate the defeasibility, even if you say that you can, because you don't have formally the monotonicity property. But the way you lose monotonicity is the way in which a relevance logician loses monotonicity, not the way in which you want to lose monotonicity in order to account for defeasible inferences. So, like it's not only a matter of whether you are technically monotonic.
So as a linear logician, the point was not about why is it exotic or something like that, or just to understand the choice. And in particular, there is no reason not to consider a purely reversible formulation of classical logic. Depends of the objective anyway. But there is with respect to the goal, to this idea, to justification, making explicit the reason, and so on and so on, the distinction between reversible rules and irreversible rules, which is it's very important, because reversibility means automaticity or something like free circulation into in both directions. And non-reversible rules implies a choice. It's the difficult part of the justification, so to speak. And so it's a little bit strange in a way that, with respect to this goal to make it explicit the way we interact in dialectics, when we justify our argumentation, so on, there is no specific place for that, which is a point about the difficulty to justify and so on. So that was my question, more than uncomfort about that. I have no.
Yes, sorry. In previous books by Professor Brandom, it was said that its framework was not based on monological system, but on dialogical. And in fact, in a dialogical framework, it's true that it is rather easy to show that there are entitlements and commitments which are exchanged between, for instance, two locutors. And for instance, an example like the one of the Tweety is a bird, and therefore it's flying, etc. We can perfectly imagine that in a certain sense, there is a contradictor who says to somebody who says Tweety is a bird, a contradictor saying, but Tweety is a penguin. So after an exchange, it may be concluded that Tweety doesn't fly. So I would like to ask to Professor Brandom in why, and particularly, he seems to have abandoned the dialogical perspective.
Well, this is something I certainly should have mentioned in the in response to the question, where do we go from here? We've actually been very concerned to try and incorporate dialogic considerations. Had a computer program that starts off with interlocutors that in one case share a base vocabulary set of reason relations, and in other cases don't, trying to investigate what features of the reason relations, the base consequence relations they're starting with, get reflected in the results of various dialogues. The pragmatic framework we are operating in is dialogical insofar as giving reasons for as a justification, altering entitlement statuses, and giving reasons against in objection, which removes entitlement until a justification is forthcoming. These are lightly dialogical features of the very minimal pragmatics that we were working with. But I certainly have not abandoned the aspiration to do this all in a much more explicitly dialogical framework, and have looked at the work on that, with kind eyes, while not able to see how to actually integrate it into what we're doing. But I certainly endorse the aspiration and the dialogical perspective.
There last question, or someone, maybe Ulf wants to add something? Sure.
I just wanted to add to that I think the lack of the dialogical aspect in the book comes also with a lack of the historical aspect, right? So in the book, we really treat contents as if they sit still in time and across different people, as where we all share the same meanings and they are stable over time. And these are clearly idealizations that I think we would want to loosen up in future work, but those were the idealizations that we thought once we put them in place, we can get our handle on something that we find attractive, and we could get something done. So I think it's not so much an abandoning of something, but more a restriction that we have put on the work in order to get something that we were happy with, at least as we're modulo those idealizations. Does that sound right to you, Bob? Is that I wanted to add especially the historical perspective, because that's another thing in the future, if as it were, adding a dynamic perspective to the whole framework would be great if someone could do it.
Thank you for saying that, because actually that was a question I had reading the book. Hello? Right. This was a question I had reading the book. If you, because you claim there is an isomorphism between the pragmatic side and the alethic side, but if we integrate dynamics, the dynamics of a dialogue between two contestants is giving and asking for reasons, but the dynamics of a world is just a situation changing, maybe. So you know, there's two kinds of histories. There's a histories of dialogue and there is histories of change. And would your, if you added dynamics, that would diverge, because you would have two possible histories. For example, people contesting about a static situation which has moved on, or people agreeing on or the reverse, you know. So how do you add dynamics by keeping the isomorphism?
Well, I want to say, you know, the claim was never that this isomorphism holds. It's intelligible, but of course we don't know all the laws of nature. We don't know which subjunctive conditionals are true. We get to mean copper by copper because after long labor, we've gotten enough of the implications and incompatibilities right. I take Wolff's isomorphism just to show we can understand what it is for us to get it right. Dialogue, the historical development of our conceptions, that's part of the process of approximating the isomorphism, of producing it, of getting closer, more isomorphic. And the game of giving and asking for reasons is equally a game of changing our meanings and reason relations as it is of changing our commitments and entitlements. And these dialogic procedures, and the reason they can't be ignored is because that's how we're grooming our practices so as to approximate in the limit and approximate better the sort of isomorphism that would have complete understanding. And yeah, those processes are all happening on our side. One of the features of traditional readings of Hegel that I would hope to resist is seeing an analog of that on the side of the things we're talking about.
Yeah. And well, one thing that I think we can add is that ideally we would, for example, also include tense in the language that we can treat. And if we include tense, we can, as it were, at least make explicit the change that happens in the world. But that, I think, comes with some treatment of indexicality, things like that. So there's a question where once we do that, I think the language will be richer, and then the isomorphism will also have to be treated in a different sense, you know, as we're over time, how tense language is isomorphic over time in the ideal limit. Again, not, you know, the claim is not that we are there, but that we're getting there as we change our concepts, hopefully. One other thing that is not an answer, that's more another project that I think Bob, I don't think you, Bob, are committed to that, but you know, I, in my more Marxist moments, think that in the fullness of time, one has to realize that the game of giving and asking for reasons also takes place in the material world, governed by laws of nature, so that it, as where the game of giving and asking for reasons itself has to be specifiable in a sense that is governed by a lethic modality. But at the same time, it has to be governed by a normative modality, and you have to get this, as it were, at the same time in the right way to give an account of this game of giving and asking for reasons. We, as it were, treated as it stood outside of the lethic realm. Well, there's a Godized perspective that is only governed by norms, as it were, transcendental self, a numinal self that isn't really part of nature. And then you have nature that is governed by the laws of nature and the lethic incompatibility. And if it all goes well, then the two kinds of incompatibility line up. But if you have any kind of, and I don't mean reductive materialist ambitions, but even just a kind of the more lightweight, I think, Marxist material ambitions that I sometimes feel, you still want to say, yeah, but ultimately we are parts of nature, right? And then that would require another extension and complication of the whole framework. So I think there's actually tons and tons of work to do for future generations here.
I just want to say both both meta vocabularies need to include the other. I mean, talking objective lethic modal talk is talk too, is norm-governed talk. The inclusions go in both directions. That's the only qualification I would make.
I wonder how you would model a sentence like, I convinced him that Tweety could fly. I convinced, because that's a fact also in the truth maker. And also it's because of my normative giving and asking for reason. So I guess that would be quite complex to model, to convince, to state that I convinced him of something. No, maybe, I don't know. Thank you.
Thank you very much.